All right, so in this video, we're going to go over sections 4.2, 4.1, and 4.2. This is sort of going to be an introductory section. We will get more involved when we get back to class. All right, section 4.1, and this entire chapter is really about applications involving triangles, being able to solve triangles using the trigonometry that we know and use them in application problems. Section 4.1 is specifically looking at applications involving right triangles. In this video, we're not going to look at any actual applications. We're just going to look at how we solve a right triangle and what we mean by solving right triangles. First thing I want to do is get us together with this notation. Right triangles all have one right angle. So as you can see, I have my square here notating my right triangle. And we usually notate angles using a capital letter and side lengths using a lowercase letter. And notice how I have these sides and angles labeled. Across the triangle from the right angle, sorry, not right angle, but from angle A is side length A. Across the triangle from angle B is side length B. And across the triangle from angle C is side length C, right? So we have capital C here representing the angle, lowercase c across the triangle representing the side length C, right? We're always going to notate our triangles like that. It doesn't matter where we put the actual angles as long as we remember that across the triangle from the angle is the side length with that same letter, but it'll be lowercase, all right? So pay attention to that notation because we don't always get the picture. Sometimes I'll give you some information about a triangle or a right triangle, and you're supposed to label the picture yourself. All right. But anyway, solving right triangle involves finding the missing sides and angles. So if I give you a couple of pieces of information about side lengths or angles of a triangle, can you find the rest of the side lengths and angles, right? And the tools that can help us do that is, well, one, our Pythagorean theorem. And so if I look at that right triangle that we have there, a squared plus b squared equals c squared. So if I know two of my side lengths, I can find the other side length using that theorem there. With all right triangles, the angles that are not right are complementary angles. So we can use the fact that complementary angles, not the theorem, the theorem was a little different. If I add up the two angles that are not right angles, in this case angle A and angle B, they should sum up to 90 degrees because the sum of your whole triangle is 180. So if this one is 90, then these two together have to be 90 in order for us to get a total of 180. All right, and the last thing that we can use is some trig functions. All right, we may use a sine, cosine, or a tangent in order to help us figure out some of the missing sides or angles. Well, sides, basically. All right, so let's look at an example. And it says the direction is solve the following right triangle. We're going to round to 2 decimal places. Notice here, I know in the last chapter we were stuck on radians. We're going to move back to degrees because in application problems we use degrees more so than anything, okay? And so if I look at this right triangle here, side length A is here, angle A is up here. If this is C, then I know that this right here is angle C. And if that was A, then the only other option is for that to be B. And then that means that this is lowercase b, right? Just getting used to the notation. But we want to solve the right triangle, right? And that means we need to find the missing pieces. Angle A, side length A, and side length C, how big they are, all right? When I use A, B, and C, I'm meaning the measure of those things. And I know sometimes you'll see in geometry, something like that. That means measure of angle A. Well, I'm not going to use all that notation. I'm just going to say A to represent the measure of angle A. And I'm going to say B to represent the measure of angle B. I'm just shortening the notation, all right? But first, if I were going to solve this right triangle, the first thing I would find is side A, not side A. Angle A. I'm going to use my eraser here. I got to get used to this. Hadn't done this in a while. But the first thing I'm going to do is I'm going to find the measure of angle A. All right, and I'm going to use the fact that angle A and angle B are complementary angles. So if I want to know the measure of angle A is going to be 90 degrees minus 10 degrees, which is 80 degrees. And so I know that this is 80 degrees. And so now I know all my angles. This one's 90 because that's the right angle. That one's 10, that one's 80. I know side length B. I don't know C or A. Well, let me go and find side A. Okay, and this is where my trigonometric functions, my trig ratios come into play. All right, if I want to find side length A, and I know B, but I don't know A or C, then I'm going to see which trig function uses this side length here as well as side length A. And the only function that uses opposite and adjacent is our tangent function or our cotangent function. Since our calculator only has and I guess if I focus on this angle here, I'm going to use my tangent function. Tangent of 80 degrees. I'm not going to use sine or cosine because sine and cosine uses angle C, and I don't know angle C here. So I'm going to use my tangent function and say tangent of 80 degrees equals A, which is side length A, which we're looking for, over the adjacent, which is 4 units long. Okay? And then if I multiply both sides by 4, I'm going to get 4 times the tangent of 80 degrees equals A. And that is what I'll put in my calculator. And once you put it in your calculator, you'll see that if I round that to 2 decimal places, I'll get approximately 22.69. All right, so this side length A here is approximately 22.69 units. All right. And so remember, I'm going to try to use either sine, cosine, or tangent because that's what my calculator has. And so since I'm focusing on the 80-degree angle, then I'm going to use opposite over adjacent for tangent. You could use the 10-degree angle and do tangent as 4 over A, right? Tangent of 10 degrees equals 4 over A. That's another way that you could do it. But I chose to use the 80-degree angle. All right? And so now what I'm going to do is I'm going to find the only other side length that we don't have, which is side C. For me to find side C, I have a couple of options. I can use my trigonometric functions, or I can use my Pythagorean theorem. One option is better. I'll tell you why. The option using the trig function is better because I don't have to use an approximation. Notice this 22.69 here, it is rounded, it is an approximation. So if I use my Pythagorean theorem by doing a squared plus b squared equals c squared, then I'm going to be using the approximation for a, which is not going to give me the best answer when I solve for c. So what I'm going to do is I'm going to use my trig function to find c, and what I'm going to do is I'm going to use the relationship using these two angles here, which are exact. All right. Side length B is 4 units. Side length C is what I want to find. And I can use a trig function, either the sine or the cosine function, because this involves the hypotenuse in order to help me figure out what side length C is, right? And so I'm going to say, let's say I use sine. If I want to use sine, it would have to be sine of 10 degrees equals the opposite of that 10-degree angle, which is 4 units, over the hypotenuse, which is C units. If I solve by multiplying both sides by C, kind of like cross multiplying, and then divide both sides by sine of 10 degrees, I'll see that I have C rounded to 2 decimal places as approximately 23.04 units. And so I have C is approximately 23.04. And so that concludes what I need to do in order to solve that right triangle. I've been given 2 pieces of information, the measure of angle B and the length of side B, and I was able to use the fact that angle A and B are complementary angles and some of my trig functions in order to help me figure out the rest of the missing pieces. And that's solving a right triangle.